Welcome to Study Loop.
This is problem 100 in chapter 7.4 in vector mechanics for engineers, statics, and dynamics. So for this problem, there is a cable stretching from A to E, and there's a load applied at B, which is 2 kips, at C, 2 kips, and at D, 2 kips. The horizontal distance from A to B is 6 feet, from B to C is 9 feet, C to D is 6 feet, and D to E is also 9 feet. The vertical distance from A to E is 7.5 feet. And I just want to point out everything is not drawn to scale. So for this problem, problem A, we need to find the distance of C, which is the vertical distance from C to E, if the cable from B to C is horizontal. And B, we need to find the E components. So to start off this problem, we are going to draw a free body diagram from C to E, and we're going to add in the reaction forces for E. Ex is in the positive x direction, and Ey is in the positive y direction. So we're going to start off with finding the sum of forces in the y direction and set that equal to 0. And it's going to be positive Ey minus 2 for the loads. So in simplifying and solving for Ey, it's going to equal 4 kips. Okay. Next, we're going to do the summation of the moments around C, set that equal to 0. And that will equal Ey times 15, because there's 15 feet in the horizontal direction between C and E. Then minus Ex times dc minus 2 times 6. And this is the load at D. It creates a clockwise moment around C, which is negative, and it's times 6 because there is 6 feet in the horizontal direction between C and D. So in simplifying this, we get 4 times 15 minus Ex dc. We'll just set that. We'll move the 2 times 6 to the other side, which is 12. So in isolating the Ex times dc, that will equal 48 kip foot. Okay. So moving on, we will go back and have the free body diagram from A to E, and that B to C segment is horizontal now. So we're going to do the moment about A set equal to 0. This will equal Ey times 30 because there's 30 feet in the horizontal direction between A and E, minus Ex times 7.5 because it's times 7.5 because the vertical distance between A and E is 7.5 feet, minus 2 times 21. And this is the force at D. It creates a negative moment around A because it is in the clockwise direction. It's times 21 because there's 21 feet in the horizontal direction between A and D. Same goes for the force at C. It's just 15 feet between A and C in the horizontal direction. And then for B. Okay, so simplifying this, we still do not know Ex. And then all of these loads also calculated in. And then you're going to set it equal to 0. Go ahead and solve out. Ex will equal 4.8 kips. And luckily from up here, you can actually bring this down and calculate it out for dc. So Ex dc equaled 48 kip foot. So we're going to go ahead and plug in the EX that we just solved for. Okay, so DC equals 10 feet. And this is the answer to part A. All right, and we actually already solved for part B within the problem. We already solved for EX, which is 4.8 kips, and EY, which was 4 kips. And those are the answers to part B. And that is problem 100.